All right. Welcome, everybody. Thanks for joining our session today. We may give it just a minute or so for folks to join before we get started. But we don't want to wait too long. We want to be sensitive to everyone's time. So welcome to the community webinar for today. My name is Randy Arseneau, and I am very happy to be joined today by Ryan Goodson from Red Hat. And together we're going to be taking you through the content. So thanks, everybody, again for joining. So I'm going to give it just about 30 seconds or so, and then we'll go ahead and get into the material. So we're going to take, this is about a half-hour session, but we're definitely going to try to allow some time for questions. So if you have a question during the course of the session, there is a Q&A panel on the bottom of the interface here. Please feel free to put your questions in there. And time permitting at the end, we'll also try to open it up and take some additional questions as we go as well. So why don't we go ahead and get started? So hopefully everyone is able to see the initial slide, the opening slide here. If not, please let me know, and we will do a quick audible, but I'm assuming that we're okay here. So again, thanks for joining us. My name's Randy Arseneau. I am part of the product management team at IBM for the Fusion product family specifically, although I work across the portfolio. And I'll let, when Ryan comes up, I'll let him introduce himself. But Ryan is one of the kind of global rock star deployment specialists and black belts for OpenShift. So the subject matter for today, how to deploy OpenShift faster by taking advantage of some of these technology solutions. When we had the opportunity to present this, Ryan is the first name that came to mind because he's kind of the guy who does the largest, multiple thousand core OpenShift deployments worldwide. So he is a deep domain subject matter expert on OpenShift and a really perfect collaborator on the presentation. So without further ado, let's get into it. I want to start off by kind of setting the stage a little bit on why we're talking about this topic and why it's so important and relevant right now. So most of you probably know, depending on what you're, whether you're kind of a partner or an implementation person or a salesperson or a tech seller or whatever your role might be, an end user, constituent, or a practitioner, there's a kind of major wave or trend that's been in our industry now for a couple of years that's really picking up a lot of steam and a lot of momentum. And it's something that a lot of us are kind of thinking about, a lot of us are making pretty significant strategic investments and a lot of decisions about, and that is around the whole concept of modernization and digital transformation. It's a huge thing. It's very kind of amorphous. It means a lot of different things to a lot of different people. So we want to specifically talk about how modernization is leveraging technologies like containerization and in particular OpenShift, and how that can be used to accelerate modernization and, more importantly, to overcome some of the challenges that come along with these large-scale modernization and digital transformation initiatives. So, again, this is the kind of thing everybody is thinking about this. Everybody's talking about it. Everybody's actively doing it. Everybody's trying to go, through these modernization journeys. And it's, a big investment in most cases, especially depending on the size and scope of the project. It's a, multi-million or billion-dollar initiative. So it's kind of a highly leveraged, board-level discussion in many cases. But there are a lot of challenges. There's a lot of struggles with this kind of broader modernization effort and initiative. So we want to talk a little bit about what some of those are. So, probably not surprisingly, if you look at just about any analyst research, you'll see that most workloads are presumed to be cloud native. This is a particular Gartner data source, but there's many of others, predicting that by 2025, 95% of all enterprise applications will be cloud native. Now, to be clear, cloud native does not explicitly mean running in public cloud. It simply means being delivered using a cloud-like distribution and deployment model and consumption model. So it's generally going to be more of a hybrid deployment where it's a combination of on-prem and typically multiple public clouds. However, there is likewise a lot of research that demonstrates that a lot of organizations are really struggling. They're having a very difficult time meeting their delivery objectives, meeting their scheduling objectives. They're over budget. They're having a lot of problems. And it has to do with things which, again, probably aren't a big surprise. Containerization and Kubernetes development skills and architectural skills are in pretty short supply. There's not a lot of these people available. These resources are scarce. They're hard to find. They're very expensive. So there's often kind of a skill gap in many cases. The tools and the layers of instrumentation and technology enabled to do this are fairly complex, so they can introduce additional levels of complexity into what can be an already fairly complex IT infrastructure environment. And one of the biggest ones that we hear from customers a lot, and I'm sure Ryan has some kind of war stories here too, is everybody, as they embark on this journey towards modernization using containers and microservices and some of the technologies we're going to be talking about, they generally do a pilot project first. So they'll do a small scale kind of isolated program where they'll kind of do some initial workloads, and that typically goes really well. But then as they begin to migrate those workloads into production at global scale, they very quickly start to uncover challenges, limitations, vulnerabilities in their infrastructure that can create problems and create risk that's very difficult to overcome. And we hear this all the time from customers. It worked great in my pilot environment, but when I tried to roll it out into production, I immediately had performance issues, scalability issues, reliability issues. So how do we prevent those things from cropping up prior to that production, promotion? And what are some of the things we can do to help mitigate some of that risk? Now, the good news is those organizations that figure this out and are able to develop a good methodology and a repeatable set of best practices for modernization and transformation get some really significant benefits, right? So it becomes as the name implies, kind of a very transformational thing that can result in great benefits for agility, business performance, better competitive posture. So it really becomes more of a technology discussion and much less of a technology discussion and much more of a business value discussion by being able to take advantage of public-private, cloud and sort of on-premises infrastructure in a very seamless, well-integrated and well-orchestrated way. There's tons of benefits. You can take solutions to market faster. You can develop fundamentally new ways of doing business and competing and do so faster in a more repeatable and more cost-effective way. So again, lots of benefits. So it's kind of a high-risk, high-reward situation for a lot of this stuff. And our goal is to help customers achieve these things and do so in a way that mitigates a lot of that risk. So I like to think about sort of containers and microservices as a logical evolution of a lot of the things that those of us who've been in this industry for a while are pretty familiar with, right? So if you think about back in the mainframe days, it was all sort of batch-oriented, very vertically integrated stacks and deployment models. We then moved towards distributed computing with PCs and server-based computing and client-server. We then moved aggressively into virtualization, which is still very prominent. Then as kind of AWS and some of the other early, Apex hyperscalers came to bear, cloud and sort of the cloud model became prevalent. And now we're evolving into containers and microservices being driven by some interesting trends. So not unlike the early days of the mainframe and distributed computing, where it was kind of cost and productivity and, time to market. As you move into the present day, it's being driven by more, I would say, kind of higher order requirements around analytics, machine learning, IoT, AI, the ability to deploy using DevOps and agile development and deployment models. So the demand domain has changed and the technology has evolved to accommodate those changes. But the bottom line is that it's still all about kind of transforming the way you do business and really fundamentally architecting your environment to take advantage of the prevailing technologies. Now, I think this is kind of an interesting slide. I like to show this because it demonstrates in fairly stark terms how fast things are changing and how the rate and pace of change, again, not surprisingly, has really, really accelerated. So there was an interesting study done a couple of years ago talking about the number of years it took various technologies and various, workloads to reach 50 million users. So starting back in the early days of commercial airlines, for example, it took 68 years before commercial airlines globally had reached an average of 50 million passengers per year. It took automobiles 60 years, and I won't read through all of these. If you fast forward to about 3 or 4 years ago, I guess it was more than that now, probably 5 years ago when Pokemon Go came on the scene, it took 19 days for Pokemon Go to reach 50 million users worldwide. And of course, it continued to explode in growth. So the moral of the story here is that, in the current operating environment where companies are trying to deploy these systems, the time domains are very, very short and extremely demanding. The risks are high. The barriers to entry can be very high. And the cost of failure, quite honestly, is also very high, right? So they can't really afford to take their time and sort of think through this in a in a particularly, prescriptive and thoughtful way. So this is kind of just setting the stage for sort of the environment we're living in and why technologies like OpenShift and like IBM Stored Fusion are so important to help prosper and survive and thrive in this environment. So with that, I'm going to turn the mic over to Ryan, who's going to take us through a discussion around specifically OpenShift and what it is able to bring to bear on this discussion. So Ryan, over to you.
Awesome. Thank you. And again, so my name is Ryan Goodson. I'm a principal architect with Red Hat, and my particular specialty is how to scale OpenShift at our customers and how to use that as a stepping stone to the cloud. So the container platform that we deploy is really about trying to bring that cloud-like experience into the data centers. So easier deployment, so make it easier for the application teams to be able to move across their environments by standardizing the platform and by leveraging containerization, being able to standardize the artifacts that are moving from dev to UAT to production. It allows a smoother transition into that production environment. It's also easier to manage because it's declarative from an application standpoint. You declare how you want your application to be deployed on the platform. And then the platform provides all those necessary support services to smooth the integration of that application with those downstream or even upstream dependencies. And by leveraging the OpenShift environment in both on-prem and in the public cloud, it gives a consistent user experience, not only from the application side, but also from the management of the platform itself. So with that, though, the container platform also has that traditional data center management layer. So being able to tie it into the security tools at the platform level and provide the level of visibility that is required in today's environment, being able to dig into the network traffic as it's going across, and also being able to integrate with the legacy on-prem services is something that the OpenShift environment can be used as a bridge to the legacy or vintage environment and that cloud native ideal that everybody is moving towards. However, there are challenges. Most environments today, and especially all of the ones that I've dealt with, which is mostly on the financial services side, is that everybody is very, very siloed. So you have your dedicated networking team, and you've got your server team, and you've got your VMware team, and you've got all of these various teams that all operate independently. However, OpenShift and in turn Kubernetes is a platform and actually needs to have all of these integrations to be able to provide all of the services that the application teams need in a modern development environment. And so, it's everything from IP address management, DNS, to load balancers and firewalls, but also integration with storage, whether it's file storage, which is what most people are using today, block for those high performance pieces, and the move to object storage, which allows, really getting into that cloud native ideal from the storage aspect. And so having those integrations is actually key to having the platform be successful. And it's one of the reasons why we're able to, at one of my customers, where we're able to actually deploy over 700 OpenShift clusters, and they're running nearly 1 million cores across all environments globally. And so because we took this approach to it, they were able to manage and scale and deliver what those app teams really required. And what we really discovered out of that is that it takes an entire ecosystem to deliver the platform. And as Randy was saying about earlier, is that everybody is when they do that first POC, they're so focused on the OpenShift platform, which is the heart of the ecosystem, but because they don't think about these other integrations, they end up hitting those limits. and running into challenges where as they bring more and more varied workloads on, the platform doesn't have the integrations necessary to support those. So I like to use this to really kind of highlight all of the different pieces that are required to be integrated into the container platform to be able to provide the service that is required in the modern data centers. So everything from your integration with your authentication services, being able to host um, uh, uh, sorry, the regular security services, being able to do image scanning both at build time and also on demand during runtime, integrating with the existing monitoring and logging tools. Integration with the automation platforms, being able to provide the various types of storage natively from within the platform, hosting a number of different runtimes, to be able to support all the various workloads that are out there. Being able to couple all of that with with a local copy of the data services using things like Postgres and Mongo, and then even getting into a Kafka for doing that data bus. And then eventually integrating in with all of those development tools to give that seamless experience for being able to deliver that smooth road and path to the platform, and then promotion of the code to production. Because ultimately, what we're after here is the fast and safe delivery of code to production. And the faster and safer we can do that, the more the business can take advantage of these investments. So with that, how can IBM Storage Fusion really help? So Fusion provides those data services that are needed, and it's independent of the traditional storage teams. Every engagement that I've worked with, when we go and chat with those storage teams and talk about integrating in, they're really hesitant about having that dynamic and deep integration of Kubernetes into their storage platform, and they feel like they don't really have a whole lot of control. And then layer on top of that, trying to manage backups and restores and retention and failover and DR and replication. And especially when we're talking about, getting into massive scale, the data replication pieces get very, very challenging. And traditional storage platforms aren't really geared for it. But this is really where Storage Fusion comes into play. As part of the package, we have these integrations where we create these custom resource definitions for the backup and retention policies. So we could actually select by label how a particular namespace needs to manage their backup and retention policies, and I just subscribe to it. So if you have like a tier 3 type of application, well, you have a tier 3 backup and retention policy, and based off of the tags of the namespace, it'll automatically subscribe, and any storage that's being consumed will automatically get that backup and retention policy. Same thing with the data replication. The platform can support metro replication for active-active between two clusters that are near each other, but it can also do the regional for business continuity, being able to fail over to that DR site. And then another aspect to that is that, of course, the ROM and DR piece, which for those first applications that are not quite ready for managing data replication at the application level, the ROM and DR piece comes in and can actually help manage the failover to another Fusion cluster by leveraging the data replication and ROM and DR, with it being able to recreate all of the Kubernetes objects from the deployment on one cluster, and then be able to stand it up on the next one. So again, allows you all of those traditional data center services that a lot of these legacy apps still have to rely on as they're going through their modernization journey. And that gives the app teams a lot more flexibility to get into the platform, take advantage of these services, and give them an option to be able to refactor their application by leveraging the consistency that containerization and the OpenShift platform provides. And with that, there are two primary deployment options for the storage fusion. There's the HCI, or the hyperconverged infrastructure, which is an engineered solution, which is the hardware and software all integrated together and delivered to the customer site. And then there's also the SDS, or the software-defined storage option, which will layer on an existing OpenShift environment, and it can be deployed anywhere. So it can be on the traditional VM environment, but also onto the cloud providers, and be able to provide all of those storage services out of the box with that deployment. And so with that, I'm going to go ahead and hand it back over to Randy and let him continue on with those details.
Awesome. Hey, thanks, Ryan. Great stuff. And this is exactly why we had Ryan come on, because nobody knows this space better than he does. And he is also very much a subject matter expert when it comes to deploying OpenShift. So thanks again, Ryan, for that. And Ryan's also like any good commercial airline pilot. He wants to make sure your OpenShift cluster gets there fast and safe. So remember those things. We're all about deploying fast and safe. Okay, so let's wrap up. How can we help? How can we work together to help achieve the things we've talked about, overcoming the challenges we talked about at the top? How can we achieve the state of, successful, fast, safe platform deployment that Ryan talked about? So Fusion is our engineered solution designed for this domain, for this space. So the whole idea behind this is anywhere OpenShift runs, Fusion is available and can run and can be made available, whether it's in the software deployment model or the hyperconverged appliance, the infrastructure model, fast, reliable, easy support. So you have a single phone call to support the entire stack. This, by the way, is one of the big reasons that we brought Red Hat into the IBM family of companies and technologies a few years ago, so that we could deploy this full stack, top to bottom solution that really delivers a complete engineered solution from the end user with a consistent user experience all the way down to data residing on media, whether it's in the public cloud, on-prem, or any combination thereof. So that's really the whole, concept and design ethos behind Fusion. Quickly, just leveraging on what Ryan talked about, within most organizations, especially as they're undertaking these modernization initiatives, there's this kind of pipeline approach or pipeline flow where developers are working with architects and platform engineers and ultimately SRE teams to take code, assemble it into workable, meaningful, reliable, secure applications, and then deploying them at scale in a very agile and cost-effective way. The point here is that for each of these teams, there are elements of Fusion that makes them more productive and also enables them to sort of interoperate and collaborate more efficiently and more effectively, right? So whether it's enabling developers to consume resources as Kubernetes operators and custom resource definitions, whether it's kind of the automation capabilities and the very well-documented APIs, whether it's the fact that OpenShift and Fusion are built on well-documented, well-established open standards that are very well supported by, literally thousands of commercial and open source software products and solutions. So great solution for the entire workflow, optimizes it, accelerates it, provides better communication, and delivers for each of these groups what they need, when they need it, in a very easily consumable way. So it just makes the whole process more efficient, more repeatable, and more reliable. So again, as Ryan mentioned, Fusion is a single solution available in kind of two flavors or two deployment models. There's the software version, and then there's the pre-integrated appliance version, the HCI solution. They share a lot of common things across them, whether it's the basic console interface, the management interface, the data protection and data resilience and disaster recovery capabilities, and then also the kind of data foundation layer. There are some differences between the two, which are kind of beyond the scope of this discussion, but the point here is that it is a single solution designed to support OpenShift running anywhere. It, of course, supports IBM Cloud Paks and is very tightly integrated with IBM Cloud Paks. That's kind of our route to market for our software solutions, which, by the way, is also built on OpenShift. So the point here is that OpenShift anywhere and everywhere, Fusion is designed to overcome a lot of the challenges and deliver on the promises of OpenShift deployment. The competitive advantages we have, there was a survey that was published by Evaluator Group recently where they looked out and surveyed about 1,000-ish global companies and asked them to report on some of the characteristics of their containerization environment. And it turned out that the number one most deployed data services solution for Kubernetes is, in fact, Fusion Data Foundation, which had previously been known as OpenShift Data Foundation. For those who aren't aware, as of January 1st of this year, the data services functional unit from Red Hat has moved into IBM and is now part of IBM. So we brought over OpenShift Data Foundation as well as Ceph, and those are now IBM, kind of branded products. They will continue to be upstream open source first. That is not going to change. They will simply be, rebranded and renamed as as IBM products rather, and will continue to be delivered as part of, for example, OpenShift Platform Plus, that's delivered by Red Hat. So, kind of a closer collaboration, bringing the data services elements into IBM, which is going to allow us to, continue to innovate and accelerate the pace of innovation for both of those, as well as support the number one most deployed data services platform in the industry already. So great competitive differentiation, specifically as it relates to things like data protection, backup recovery, disaster resilience, and disaster recovery. So there are some pretty sophisticated capabilities that you don't get with basic data services and Kubernetes that Fusion provides. So remember, we talked at the beginning about sort of the challenges that can be associated with taking OpenShift applications and clusters from the pilot phase into production. This is one of the many ways that we're able to improve the quality of that transition process, the reliability, and simply the success rate. So, we want to help you and your customers be part of the 30% that succeed and not the 70% that we talked about earlier that struggle and have challenges. So that's the whole kind of design ethos behind this. We talk a lot often about sort of cloud packs and how Fusion obviously supports our cloud packs, but equally important, perhaps more important, is that it supports any application that runs on OpenShift. And again, as I mentioned, there are literally thousands of titles, both open source and commercial, that are deployed on OpenShift. So anything you see here and many, many, many others are all able to be run on Fusion, with all of the benefits we've spoken about, including the ability to get very easy, very high quality support with one phone call from IBM. We handle the triage, we handle level 1 and 2 support, and we will escalate to Red Hat or others as needed. But again, if you're running an enterprise, global scale production workload, it's comforting to know you've got that level of support. You don't have to have these sort of 3 a.m. panicked search on, Substack and Reddit or wherever you're looking for your open source support. So kind of hardens the process and makes it a lot easier to deliver. So that brings us to the end of the material. The QR code you see here will kind of connect you to some additional resources that you can learn more about Fusion. Of course, feel free to reach out to Ryan or myself. We would be glad to answer any questions you may have. When you go back to the content or when you kind of look at the material on the title slide, our email addresses are there. So feel free to reach out to us. But with that, let's just take a quick look and see if we have any remaining questions. We wanted to, again, be sensitive to everyone's time and make sure we locked it up within 30 minutes so we can keep you on track. And it looks like there are no remaining questions at this point. So I guess we'll wrap it up here again. Thank you, everyone, for attending and for joining us today. We appreciate your time, your investment of time. Thank you, Ryan, for joining me and co-presenting. Thank you to the organizers for helping us orchestrate this event. And with that, we'll close it off and say thanks again, and we'll talk again soon. Thank you, everyone.
Perfect. Thank you so much to both of our presenters. You guys did a wonderful job today. Just a few reminders to everyone in the audience. We will email you the on-demand recording and the slides later on today. There will also be links to connect directly with all of our experts from the IBM community. This concludes today's webinar. Thanks for joining us around the globe, and we hope you have a great day. Thanks, guys.